So next thing, Roman numeral 10. This way now. Factors of transformation. So thing here is so this is what I was trying to get at way at the beginning of this video. And it's this. This sentence says it beautifully. The virus can act as ligand, receptor, transducer, or transcription factor that transforms cell. So I was trying to, okay, so for this, it's kind of related. I'm trying to say that the virus can encode, some retroviruses encode a gene as a cellular homolog of an oncogene. Others, other retroviruses can mess up the cellular oncogene. Other and even other retroviruses, it can simply encode a gene product, a protein product, that might turn on or turn off or accept a cell gene product, and that will turn on uncontrolled cell division. So the whole point is the virus can act as a ligand or as a thing that causes transformation. It can act as the thing that accepts the thing. It can act as a receptor that accepts the thing that transforms the cell. It can be the middleman that transforms the cell, or it can be the thing that, it can be a transcription factor. It can be what tells the cell to change. And if we were to draw a quick diagram of that, here's the nucleus. Transformation can occur here. Yeah, your stimulus. You see, you can have your ligand, your receptor, transducer, transcription factor. Okay, basically, the cell can act as any of these four things to mess up a cell and turn it into a cancer cell. Probably should give you guys more time. Oh, no, we're going to Tina. Okay, now I'll give you guys better warning. I'm trying to rush through these videos. I should give you guys better warning when I'm going to erase. Transformation. I'll do that next. Okay. So that's star whatever. Okay. Now we're going to get into the bullet points. So as a ligand, so the virus as a ligand of transformation, the virus can act as ligand growth factor. think VSIS, which is a platelet derived factor. So there's a handout. I'm going to cover this in the handout when I do my handout videos. The virus, again, can act as a ligand growth factor, so something that binds to a receptor. And a good example of that is the platelet is the VSIS, which acts as a platelet-derived growth factor. So basically, this virus can attach to, or one of its genes products can attach to a cell receptor in the cell, or just any receptor, and then it tells the cell to start dividing uncontrollably to become a tumor. As a receptor, virus can act as receptor for ligands. Here I think VERB. Remember, V stands for viral. So VERB. VERB, beta B, epidermal growth factor receptor. So from what I understand, these are the stuff in parentheses is the cellular homolog, the VSIS or the VERBB, that's a viral homolog. So in our cell, there's this thing called epidermal growth factor receptor. But the virus, retrovirus, has a viral homolog called VERBB, which does the same thing as this. But now since there's a shit ton of the virus, and likewise with this gene product, with this receptor, you now have uncontrolled cell growth. Yeah, another good example, VERBA. So the cellular homolog in parentheses is thyroid hormone receptor. So someone, excuse me, without cancer, without anything, I have thyroid hormone receptors in my body, and they accept the thyroid hormone, and all's good. I don't have too much of the receptor because I don't want cancer. I don't want too little receptor, because I want to be able to grow still, replace cells and everything, metabolize energy. But with this stupid VRBA, now there's a bunch of basically this. Now my cells are told to divide constantly, which is what I don't want, and you get cancer. And then, as an adapter, or also known as a transducer. Just put as a transducer. It's really messy. You have stuff like your V-start, your V-able, your V-RAS. So we already covered V-start. Remember, it all phosphorylates itself, and then it messes up the signal transduction pathways, and you get increased cell growth. You get cancer. Okay. And finally, there's the. Okay, so I'm going to erase this. 3, 2, 1. As a transcription factor. So think VGU, think VPhos. And in parentheses, the cellular homolog is AP1. So remember when we were covering Polyomaviridae, I think it was, oh man, can't believe I've already forgotten what it was. Its large T antigen messes around with the AP1, and then you get increased cell growth. Increased cell growth, you get tumors. Or increased uncontrolled cell growth, you get a tumor. And obviously the virus wants to increase the cell growth because its genome is integrated into cell genome. So you increase the cell growth, you increase the number of viral genomes and proteins that are made, replicated and made. And as a side effect, you get tumors. Does the virus care? No, but we care. Okay, so I will now next Roman numeral, cell wall system. Okay, so now we're going to cover. We'll go into a bit more detail of all the various factors of transformation.